You are welcome to our class for today. In this class, we are going to be looking at our second numerical on shear force and bending moment. Of course, we are still on the simply supported beam with concentrated load cases. So we are solving numerical on that. So the numerical we have on the board is nothing but numerical 2, which says that we should draw the shear force and bending moment diagram for this simply supported beam. The beam has two concentrated load, one 4 kilonewton and another 2 kilonewton, and of course it's over a total distance of 4 meters. So we are asked to draw the shear and bending moment diagram. So let's proceed. So like how I did in my previous video, I'm going to be drawing the shear force and bending moment diagram here, and I'm going to be solving the calculations here and there. So the first thing we are going to be doing is that we are going to be taking the sum of we know that the sum of upward force is equal to sum of downward force. So that's the first thing we are going to be doing. We are going to be summing our upward force, equating them to our downward force. Now the upward force I have here is what? Is nothing but RB and what? And RA. Of course, these are supports, and definitely there will be a reaction. So our RA plus RB will now be equals to what? 4 plus what? Plus 2. So let's do that quickly. So first thing first, sum of upward force equals to sum of downward force. Definitely R subscript A plus what? Plus R subscript B will be equal to 4 plus 2. 4 plus 2. This implies that what? RA plus what? RB will be equals to 8. This is kilonewton. This will be, oh sorry, this is 6. 4 plus 2 is nothing but 6. So this is 6 kilonewton. This is our equation what? Equation 1. So next we are going to be taking our moment at point A. So we are going to be taking moment at point A. So summation of moment at point A is equals to what? Is equals to 0. So moment at point A will be nothing but what? RB multiplied by what? The perpendicular distance, which is what? A total distance of 4 meters, minus what? Minus 4 multiplied by 3. Now we are going to be taking like we did in our previous video, upward forces to be what? To be positive, and what? And downward forces to be negative. So this is what we have. So it's going to be 4 multiplied by what? RB multiplied by 4 minus what? 4 multiplied by 3 minus 2 multiplied by what? Multiplied by 1. I hope you get that. So our moment at point A will be nothing but what? RB multiplied by 4 minus what? Minus 4 multiplied by what? Multiplied by 3 minus 2 multiplied by 1. Everything equal to 0. I hope you get this step that I just explained here. So next, 4 times RB is nothing but 4RB. 4 times 3 is nothing but 12, and 2 times 1 is nothing but 2. So I have 4RB minus 12 minus 2 to be equal to 0. So this implies that what? This implies that my 4RB will be equal to, or let's not jump. So we have 12 minus 12 minus 2. This is nothing but what? This is nothing but minus 14. So we are going to be having minus 14 equals to what? Equals to 0. So 4RB will be equal to what? Will be equal to 14. So our, if we make RB the subject, what do we have? 14 divided by 4 is nothing but what? 3.5. So RB is equals to what? 3.5 kilonewton. Don't forget your unit. So now from equation 1, we know that RA plus RB, from our equation 1 here, we know that RA plus RB is equals to 6. Is equals to 6. So if we substitute the value of RB, it implies that what? Our RA will be equal, we have RA plus what? 3.5 to be equals to what? To be equals to 6. So RA is equals to what? 6 minus 3.5. So 6 minus 3.5 is going to give us 2.5. So our RA will be equals to what? 2.5 kilonewton. So this is our value for RA and this is our value for RB. So we have our reactions now. So we can therefore say that RA is equals to what? 2.5 kilonewton, and our RB is equals to what? 3.5 kilonewton. I hope you understand even up to this point. So now we are going to be calculating our shear force and our bending moment calculations. So let's start with our shear force calculation. So we have our shear force. So this is going to be our shear force calculation. Now, our shear force calculation. So we are going to be starting with what? With point B. At this point, of course, we know that the shear force here is nothing but what? It's nothing but 3.5 kilonewton, because we have, of course, at this point we have just one force which is acting vertically as 3.5 kilonewton. So our shear force at point B will be equal to what? The reaction at point B, which is nothing but what? 3.5 kilonewton. Equal to what? S dot F subscript B will be equal to what? 3.5 kilonewton. Now for this, we are going to be considering upward forces to be positive and downward force to be negative. So let me put this here so that we don't forget to be negative. All right. Now what's the next thing? We are going to be looking for our shear force at point D. Now our shear force at point D will be nothing but what? Will be nothing but the force at this point minus what? Minus the force at point D. So this will be nothing but S dot F subscript B. This will be equal to 3.5 minus what? Because the reason for minus is because the force is acting downward. So we have minus 4, which is equal to what? Which is equals to minus 0.5 kilonewton. So this is 0.5 kilonewton. Don't forget to put your minus sign. So next, we are going to be considering the shear force at this point C. So our shear force at point C will be nothing but what? 3.5 kilonewton minus 4 kilonewton minus 2 kilonewton. So we have our shear force at point C to be equals to 3.5 minus 4 minus what? Minus 2. So this we are going to be having nothing but minus 2.5 kilonewton. So this is equals to minus what? 2.5 kilonewton. So lastly, we are going to be calculating our shear force at point A. So our shear force at point A is equal to 3.5 minus 4 minus 2 plus 2.5. So we have 3.5 minus 4 minus 2 point what? 2.5. So we have plus 2.5. So of course we have minus 2 minus 4 minus 2, which is minus 6, and we have 3.5 plus 6, 2.5, which is what? Which is nothing but 6. So our shear force is equals to our. So if you do this, you are going to be having this to be equals to 0. So we have 0 kilonewton. So this is our bending moment at all points of this simply supported beam. So next we are going to be doing our calculations for the bending moment. So I'm going to be clearing this part even as we calculate for bending moment. So here we are going to be calculating our bending moment. Yes, so let's do the calculations before we draw the diagram. So bending moment calculation. So here we are going to be calculating our bending moment. Now, like I said in our previous video where I proved the simply supported beam with a load at the midspan, you will recall that the bending moment at point B of a simply supported beam and the bending moment at point A, that is the two reactions, is equal to 0. They are always equal to 0. So it implies that our bending moment at point B will be what? Will be equal to 0. Now if I take my moment at point D here, it will be nothing but what? The force multiplied by what? Multiplied by the perpendicular distance, that is 3.5 kilonewton multiplied by what? The distance, which is what? Which is 1. Of course, we are going towards what? Towards the left direction. So I'm going to be having bending moment. So the bending moment at what? At D will be equal to what? My reaction there, which is 3.5 multiplied by what? Multiplied by 1. So my bending moment at D is nothing but what? 3.5 kilonewton meter. Don't forget your unit. Now, also, so we don't forget, I'm considering upward force to be positive and what? And downward force to be negative. This is what I'm saying. Upward force positive and downward force as negative. Now, we are going to be considering our bending moment at point C. Now, to get our bending moment at point C, it will be what? Nothing but what? 3.5 multiplied by what? The perpendicular distance, which is 3 meters, minus what? We are using minus here because we have a downward force. So it will be minus 4 multiplied by 2. I hope you get that. So this will be nothing but what? 3.5. So my bending moment at point what? Point C will be equals to what? 3.5 multiplied by 3 minus what? Minus 4 multiplied by 2. 3.5 multiplied by 3 is nothing but, we have 3.5, which is what? Which is nothing but 10.5. So we have minus 4 multiplied by 2, which is minus 8. So this will be equals to 10.5 minus 8. Bending moment at C is equals to 10.5 minus 8, which is equals to what? This will be equal to 2.5 kilonewton meter. So this is our bending moment at C. Now, our bending moment at A, like I mentioned earlier, will be nothing but what? 0. So our bending moment at A will be equals to what? 0 kilonewton meter. So this is what we have. Now, with all this calculation, we can proceed to draw our shear force and bending moment diagram. So I will be bringing out the dotted line from each point as we proceed. So this is my lines. I'm going to be bringing out these lines, dotted. Lastly, for this point, we have our bending moment. So I will use this as my reference line. I'll be using this. So I've just traced my dotted line from point A, C, D, and B downwards, and I've drawn a reference line for my shear force and my bending moment. Of course, this is 0. This is also 0. Similar with here, this is 0, and this is also 0. Now let's proceed. Now, how do we do this? We have our shear force at point B to be nothing but what? 3.5 kilonewton, which is what? Positive. So we trace 3.5 kilonewton upwards, get a point for that. Let's take here to be our 3.5 kilonewton. So I can just mark here as what? 3 points. It will be 3.5 kilonewton. Of course, from this point even up to this point, there is no load in between, so it's going to remain constant. So we have our straight line to represent that. So this is what we have. Now, from at point D, we are having this is point D. Sorry, this is D, not B. This is D. So at point D, we are having our shear force to be nothing but what? Minus 0.5 kilonewton. So it is going to go downwards, even up to what? The minus sign. Don't forget, I told you that this is 0. So anything below this line is what? Is negative, and anything above this line is positive. So we are going to go downwards minus 0.5. So this will be downwards minus 0.5. I'm going to be taking this point as our what? Our negative 0.5 kilonewton. So this is what we have. So of course, similarly from this point to this point, no load, it remains constant. So we have this to be what? A straight line. We have this to be a straight line. This will be a straight line. This line we have here, this is minus 0.5. Now at point C, we are having a shear force of nothing but minus 2.5 kilonewton. So we are going to be going downward again. We are going to be going downward by 2 kilonewton. So from this point where we have 0.5 kilonewton, we're going downward. So we are going to be taking this point at our what, minus 2.5 kilonewton. So this is what we have. So from this point to this point is nothing but minus 2.5 kilonewton. So finally, our shear force at A is 0 kilonewton. Don't forget that this is going to continue. It's going to continue as constant. This is what we have. So our shear force at A is nothing but 0. So we are going back to 0. So this is what we have. Of course, this place is what is nothing but our negative side, and this is what our positive side. So you can just shade this. What we have as our shear force diagram. All right, now we are going to proceed to our bending moment diagram. This is my reference line. I have 0 here, I have 0 here. Anything above is positive, anything below is negative. So for my bending moment, you will recall that our bending moment at B is nothing but 0. So we have 0 here. Our bending moment at D is nothing but what, 3.5 kilonewton. So we are going to be tracing this up to any point 3.5 kilonewton. And don't forget that for a straight line on the shear force diagram, it's going to be presented by an inclined line on the bending moment diagram. So let's take this point to be our 3.5 kilonewton. So this is our 3.5 kilonewton. Let's draw this point. Good. So this is our 3.5 kilonewton. This is going to be kilonewton meter, yes, because it's bending moment. Don't mistake that. So next we are having our bending moment at C, which is nothing but what, 2.5 kilonewton. So our bending moment at C is 2.5 kilonewton. So we are going to be going downward. So let's take this point as our 2.5 kilonewton. This is our 2.5 kilonewton. So we are going to be taking this point as our 2.5 kilonewton meter. Now, finally, we are having what? We are having our bending moment at A, which is what? Which is 0. So we're going to be tracing it downwards, even up to A. To be what? To be 0. So this is what we have as our bending moment. This is what we have. So this is our diagram for our bending moment, and this is our diagram for our shear force. Don't forget to like, share, and subscribe to our channel. If you need more and more videos like this, please be sure to like and subscribe to our YouTube channel. Of course, we are going to be posting more numericals even on simply supported beam with concentrated load, uniform distributed load, varying load, and what have you. So thank you for watching. I hope you understand this video. Stay tuned for more numericals. Thank you.